All right. Hello and welcome to Enhanced Information Solutions joint webinar with SEEQ on operationalizing Pi event frames with SEEQ for monitoring golden batches, gray transitions, and startups. I'm Jack Audie, EIS's Director of Sales and your host for this webinar. Here's a quick agenda for today's webinar. After a quick introduction and a poll, we will describe EIS and what is an engineered solution. Joe Recamp will then describe SEEQ and the SEEQ tools, along with a quick demo. Anu Sharma will then demonstrate our engineered solution for using these profiles to monitor running processes. While you can ask questions at any time, we will share the responses at the end. At the conclusion of the webinar, we will post a survey. Please do complete the survey to help us improve our webinars. Some of the Zoom basics before we do get started. To ask any questions, please click on the Q&A icon. We will answer your questions either in the dialogue or at the end of the webinar. At the conclusion of the webinar, you will be presented with a survey. Please do complete the survey so we can properly gauge the value of this engineered solution. Today's speakers, we start off with Joe Recamp from SEEQ. Joe, could you please introduce yourself?
Yeah, thanks, Jack. Hi, everyone. I'm Joe Reckamp. I am a principal analytics engineer with SEEQ and also manage the part of the analytics engineering team in North America. I come from kind of cross-industry expertise with batch and pharma as my background, coming from working at GSK and Evonik, kind of from R&D, scale-up, and manufacturing. I have a background in chemical engineering from Villanova University.
Okay. All right. Thank you, Joe. Next up, Anu Sharma. Anu, please introduce yourself.
Good afternoon, folks. My name is Anu Sharma. I'm a technical team lead here at EIS. Been with EIS about 2 years. Before that, I was with OSI Soft for more than 8 years, where I was a senior systems engineer, senior field service engineer. So my expertise lies with Pi. Before that, I graduated from the University of Pennsylvania with a master's in chemical engineering.
Okay, thank you. All right, and I'm Jack Audie, EIS's Director of Sales and Partner Relations. Prior to EIS, I was with 23 years at OSI Soft, and I held a lot of different positions there. In fact, I probably worked with many of you on this call. My education is, also a chemical engineer. So, all right. Okay, so before we get started, I'm going to launch this poll. I'd ask you to please answer this poll, and we'll share the results. Okay, let's take a look at the results of the poll. Do you currently use Pi? 84% yes, 5% not at the site but at another, and 11% of you do not use Pi at all. Do you currently use SEEQ? 1% of you do use SEEQ, 3% not at this site but at another, and 96% of you do not use SEEQ at all. What is your familiarity with SEEQ? 3% are very familiar, 8% are somewhat familiar, 32% know what it is but have never actually used it, and 57% of you are unfamiliar with SEEQ. I hope to find out how this engineered solution applies to batch, 57%, continuous grade transitions, 19%, equipment startups, 10%, and power industry, 14%. All right, thank you very much, and we're going to proceed on with the presentation. Who is Enhanced Information Solutions? Well, we were actually founded about 28 years ago in Stillwater, Minnesota. We do MES consulting and implementation services, Pi services. We do SEEQ services, OT cybersecurity. We also have two products. One is eDataSheet, which is electronic. It allows you to manually input data into a Pi system. and it's on HTML5, utilizes AF. We had a webinar about this about a month or so ago. We also have an ops tracker product. Similar to eDatasheet, you can manually enter data, but it also has much more. It has a complete workflow, and it's an electronic logbook with workflow, and it's with a complete audit trail designed for GMP and 21 CFR Part 11. We are a global company. We're located here in our brick and mortar offices are in Minnesota, in the US, in Toronto, Canada, San Juan, Puerto Rico, Dublin, Ireland, Mannheim, Germany, Pune, India, and Istanbul, Turkey. So we have over 20 plus years of Pi experience and provide traditional Pi services, installing a Pi system and interfaces and all that. But in addition to that, we also do these types of services: AF, event frames, Pi integrator, complete validation services, cybersecurity of OT assets. We also provide SEEQ services. We do installation of SEEQ, configuring connections, whether through SEEQ Data Lab or directly through Pi, deployment, help you define capsules and so on, and training. So what exactly is an engineered solution? An engineered solution links together two or more products to solve a need. It is not in and of itself a product, but it is a lot more than an application. It's a complete solution, provides technical support and updates. So most processes here are not steady state. We have batch. Traditional batch is by definition not steady state. Continuous processes, while they may be steady, they are bound to a grade trend in non-steady state portions. So the opportunity there is to minimize those transitions, because while you're in transition, the product you're making is either has to be blended out, it's sold at a reduction as a reduced price, or worst case scenarios has to be scrapped. So we want to minimize those grade transitions. Blending operations, gasoline, equipment startups, paper machine startups, turbines, any kind of complex piece of equipment, you have certain profiles you need to adhere to. And in the T&D industry, any kind of low transitions, if you're in the T&D and you bid up to the ISO, you have your bid up and bid down rates on what you're going to provide, the power you're going to provide onto the grid. Those transitions, those load changes aren't by definition nonlinear. Okay. Now, SEEQ is used to identify these conditions using SEEQ capsules. And what I'd like to do now is I'm going to hand this over to Joe to describe SEEQ.
Thanks, Jack. So yeah, it started off, if you look at like the process data journey, it started off with really pen and paper of recording data. And as the Pi system and other databases became present in the past couple of decades, you started actually saving that data and electronically capturing that data automatically. However, we've generally run into having to struggle with spreadsheets and other things to kind of wrangle that data and get into place for any sort of analytics. And it's not really meant for time series analytics. So SEEQ came into the market back in 2015, 2016 to kind of solve this problem, to connect to the data directly, to enable the advanced analytics and bring in even that ML and AI sort of things on top of those data sets to automate that process for the end users. And so if we flip to the next slide, you can see kind of how the structure of SEEQ goes. So it starts off typically with your data sets. So you may have Pi data, you may have other data that also add some context to it, like LIMS data may have yields or potencies, quality values, stuff like that. You may have gone through some sort of cloud journey and moved stuff up to Azure, AWS, or things like that. SEEQ really connects to all that data where it is in your validated historians and leaves the data in place and gives that live connection for the users to interact with. All those connections come through the SEEQ Cortex layer, and that's also where the advanced analytics and calculation engine lives. And it hosts the kind of HTML5 interfaces at the top, your SEEQ workbench, which is really your analytics workhorse. That's where you're going to build your different calculations and analytics that you want. The SEEQ organizer, which is your dashboarding and reporting tool. And then your SEEQ data lab, which is anything that you want to do in Python. So if you want to bring in those AI, ML algorithms and things like that, that's where SEEQ data lab comes into place. And if we go on to the next slide, we can talk about how we and when we actually apply golden profiles. So what are golden profiles first? It's really that ideal operating envelope for each of the process signals. So it's giving us some sort of target that we're going to track to try and say, when are we making quality product based on the movement of these signals over time? And we'll usually have some sort of bounds around those that tell us when we actually are maybe going to achieve poor product when we run outside of these certain boundaries. And so why would we use these? First and foremost, it's to optimize the output results. So depends on what industry you are in as to what those output results are. It could be that you're trying to maximize your yield or your quality in some sort of batch process. If you're looking at more like equipment startups and things like that, you might be looking at equipment longevity. You're trying to follow a certain profile to avoid some sort of poor equipment performance, or you might have a cycle time impact that you're interested in there. Really, the key is to give yourself a real-time visualization of the process performance, so the actual value of the tag during that time frame, against those historical time trends and time periods that you're supposed to be focusing on. So what are the ideal situations and where are you supposed to be inside those ranges? And really to alert whenever there's some sort of abnormality. So when it goes outside these ranges, you want to have some sort of alert on there. And so we tend to use these for any sort of transient signals. So as Jack mentioned, there's, batches or operations or phases in like the batch world, but you also can have product grade transitions, equipment startups, or many other things where the data is really moving by default and on purpose there. And so let's jump to the next slide to show you a little bit of how this is built inside SEEQ. So it's a relatively simple process. We have a tool called reference profile in SEEQ that allows you to say, I want to apply this golden profile to a particular signal, such as the flow in this case. You can choose what you want to train the data on, and usually these are the best runs. So whether it's a single run where you just want to evaluate it against a perfect batch that you had in the past, or typically what we see is a variety of batches, maybe the ones that have the highest yield, the highest quality, whatever it might be. You can also use events and data from multiple assets. So if you had, multiple reactors running the same batch, or, multiple pumps that you're trying to follow their startup profile, whatever it may be, that's where that add signal condition pair is. You then pick a training period of time and you pick a statistic. So typically what we see is using the standard deviations as the limits and either 2 or 3 standard deviations around that. And then the average is going to be your target so that you get some sort of profile that you're aiming for as you go along. And then if we go to the next slide there, you can see that you can actually take any of these results along with other analytics that you might build out around this process and really build that historical report in SEEQ Organizer. So being able to dive into the data, add some statistics like root mean squared error, charts that help you visualize it, and let you dive around in time to kind of slice and dice the data to see where can you find those improvement opportunities as you go back in history. And I think with that, Jack, I think we're going to jump into a demo here. So let me share my screen. And hopefully you guys should be seeing my screen now.
Yes, sir.
And so we are now in the SEEQ Workbench application. And typically what this starts off with is finding, what are the time periods that you care about? So you may have these already defined in some sort of event frames, in which case we'll just connect to them and bring them in as these bars at the top of the screen. However, you can also define these in SEEQ. So we have, in this case, taken the production time frame and just said, let me find when that production time frame is happening, and created this capsule, as we call it, as an event inside SEEQ. Now, whenever this is happening, we want to then take those profiles and say, which are the best ones of those particular profiles that we're looking at? So in this case, you can select these in a variety of different ways. It's up to the end user to decide how they want to select which, batches or runs or grade transitions are their best ones that they want to focus on. But you can do this either manually, as you can see here, where they actually just selected the particular capsules at the top of the screen that they were interested in. Or you could do this programmatically by taking, the ones that have above a 90% yield or above 95% quality, whatever it may be, that you can give context through like a limb system or something like that. We then want to take that data and overlay it to see kind of what the profile looks like in relative time. So we can use our capsule time view inside SEEQ to see that profile overlaid. And we can use that to build our golden profile. So as I mentioned, this reference profile tool is what we use to create this golden profile. So we select the signal, the runs that we want to use. We select the statistic, in this case, the standard deviation, and multiplied by 2 to create the upper limit. We duplicate that with a -2 multiplier to create the lower limit, which is the bottom red one there. And then the average, which is this dashed line here, is going to be just a different statistic in there that provides that data in real time. So you're going to see that kind of target of where you want to aim for as you're going along in the process. And this can be then turned onto a monitoring view of some sort. So if you want to see the data as it's coming out, or looking back historically with the boundaries and the target against your actual signal, and flagging any sort of deviations that you may have along the way. You can also add some statistics, like maybe you want to know what the distance is away from the target that you're aiming for, or root mean squared error, things like that. You can start to add those different calculations inside SEEQ as well. Once you finish whatever visualizations and calculations you want to add to the graphic, that's where we typically flip over to our SEEQ organizer, which you can see an example of here on this tab. So you may have an overview that's looking across all your different pieces of equipment and seeing where the deviations are happening in the different pieces of equipment. And you may have some details as you go along. So maybe looking at the last week and showing you where those deviations are, having a table that counts up how many deviations, how long, gives you the root mean squared error as you're going along, some visualizations of how much time is spent deviating, and just some details as to what's happening underneath the scenes for each of these different processes. So these are just some different ways that you can visualize it. And with that, I'll pass it back to Jack and Anu to kind of show the engineered solution.
Okay. Well, actually, there is a quick question here. It comes up is, how are you determining which batches to use? Okay, can you connect to limb system or a customer database? How are you determining which ones to use?
Yeah, so it's completely up to the end user as to which batches they want to use. But typically what we see is connecting to a limb system and bringing that data in to help filter the batches for what you want. So whether you want to track for best quality, best cycle time, best yield, those may be different ways to select which batches you care about. But you can do any of those type things inside SEEQ to filter down which batches you want to use to train it on.
Okay. Okay, great. All right, moving on. So once we've created these profiles, and we're going to operationalize this in conjunction with your Pi system. So we've created these profiles, and we're going to now monitor them in real time using Pi. So anyway, so what happens here is once we've created these profiles are saved and written to Pi as future data when that actual batch condition starts and stops. Okay, so this is the profile that for example, an example that Joe just created. Those are stored, and where the engineered solution is, when that particular product launches, we go to this library of templates and profiles, and we pick out the appropriate profile, and we push that data into Pi as future data for that given product or that given transition. All right. Now, with that said, I'm going to hand this over to Anu, and we're going to do a little demo here of the actual engineered solution. Anu? Okay, so if you look here, you can see that these profiles are written out. You can see, and this is a typical Pi Vision display, the dashed line is current time. The upper limit center line and lower limit are shown, and it's projected into the future. It actually goes to the right of that dashed line. And the current value that's running is in the green. So the idea here is that basically, we want to, here's the current process variable, here's the desired trajectory for this, okay? If we go above or below the upper or lower limits, we actually have an asset-based analytic that'll create an event frame, create a notification, right? You can see here in the lower right-hand corner, you can see these process boundary deviations, and you can acknowledge those through through a PI notification. And then we also have the root mean square error, the process conformance. We're again using an asset-based analytic in this engineered solution. We're writing that value at the end of the batch into an AF attribute, which is in turn historized in a PI tag, and that RMS value is then stored. And what we're doing is we each one of those conforms to overall batch goodness. Okay, how well did we conform to that profile? On the acknowledgement, what we're doing here is we're just doing a simple, this is simple PI stuff. When you click on it, you go through a PI notification, you have an acknowledgement. But one of the things we did in a previous webinar is where we actually showed where that when you click on that acknowledgement, it actually launches an ops tracker workflow. That ops tracker workflow is an entire workflow with audit trail, sign-off procedures, and approvals, and the resultant set is then stored as an event frame, attributes for your overall system of record, all in conjunction with for 21 CFR Part 11. So it's not just, hey, we did an annotation onto the event frame. No, this is an actual event frame attribute, and we store all this information. Okay, we help close that gray space, that white space, I should say. Okay. And then, of course, the next step, if you look at it, is to take this data. It's all available. We're going to build dashboards and dashboard. That's the SEEQ organizer that Joe was showing earlier. We can show all of this data where, if you're looking here, the PI Vision displays shows you a nice tactical view of a given piece of equipment. The organizer allows you to build dashboards that looks at entire process lines, sites, and allows you to do comparisons. So it gives you a much higher level view. All right. So now, just to recap, let me take that screen back anew. So to recap, what we basically did is we used SEEQ Workbench. We created capsules of these repeatable events. We created these operating envelopes of nonlinear tolerance limits. Then we leverage that. Now the engineered solution leverages this in conjunction with your PI system. So the operating envelopes engineered solution will then monitor the process. When the appropriate product is run, we will look to that library of profiles from SEEQ, and we will apply those and write them out as future data to PI in those PI tags. The PI asset-based analytics creates event frames when limits are violated. And we also calculate out the root mean square error measuring process conformance for the batch. How well did that key performance indicator track against the center line we created in the profile? And then we bring it all home with SEEQ Organizer as a dashboard for the entire area at a higher level. So, okay. So with that said, do we have any questions out there? Okay, kind of a little bit of a quiet group here this afternoon.
Yes, I can hear you.
Okay. Do we have any other questions from any of the participants that are out there? Okay, we have one question here. What is the maximum number of conditions you can easily build this for? So if you mean the number of templates, typically what people are doing is they're building these templates for a given KPI. You pick, let's say, temperatures, levels, pressures, and flows, right? And we can determine what the process conditions are for that given KPI. So there's really not a maximum number. You can have many, many profiles, hundreds of profiles stored, and then apply them accordingly. So there's really not an upper limit at this point. Joe, would you concur with that?
That's correct. Yeah, there's really not an upper limit. We have customers that have thousands of golden profiles on their system.
Ah, perfect. Okay, here we go. Followed up. I run a paper machine with 30 different grades. I'd like to build a golden batch for each grade transition. Not a problem. Not a problem. For each one of those grade transitions, we can build a profile for that. And in fact, what EIS can do is we can build that first profile. We can work with you to build that first profile, and we can build the other profiles for you as well, right? So we can actually build them for you and work with you. So it's more than just installing. We can actually help you create those. Once we come up with one grade transition, we come up with how we want that to run. We can build multiple profiles for you. And we're doing that now with some customers now. We're building on the grade transitions. So the question is here, another question: how can a person understand how to go beyond identifying issues and start to prevent them? Well, that's the interesting part here. We can see when the condition occurs and look for that. And Joe, you guys have had some, the what if situations people are using SEEQ?
Yeah, typically the first step is to find when the issues are occurring so that you have that identified in both real time, but also in historical, because SEEQ will, when you create these golden profiles, will go back as far as your historian goes in data. And then you're starting to look for trends. So we have different tools like a correlation add-on and other profile searching type stuff to basically try and identify what are the patterns in the data sets that are relating to when that issue is occurring. So you might feed it some normal and abnormal data. You may have machine learning algorithms that you want to apply to it. Whatever it may be, that's kind of where you start to find what are the either predictive patterns in the data, either trends in the data that are happening over time that you want to fix or maybe go down for maintenance or cleaning, stuff like that, and really find what the causes may be. It does rely also on somewhat your engineering intuition. So what do you think might be the related signals or processes or causes of those particular issues?
Okay, good. We used to use the term as lowering the marginal cost of curiosity. So yeah. Well, the question is, how long does it typically take to implement from SEEQ PyAF hierarchy to SEEQ organizer? Well, we can install PyAF on a process line relatively short. We work with you, and EIS, we can work with you. And then what we can do then, if you have batches, if you already have the event frames, we can pull that right in through we can pull that right through SEEQ Data Lab, and we can pull those right in pretty quickly. If you don't have them, you can create these capsules then, like Joe was showing, and it could be a little bit of an iterative process. Joe, you want to talk a little bit about that proof of value that SEEQ offers?
Yeah, generally speaking, for SEEQ, we typically do a 3-month proof of value, and that allows you to get multiple use cases out, and this golden profile would be one of those type ones. So with entire setup of connecting the data from Pi into SEEQ, actually identifying those time periods and building the golden profiles and building those organizers on top of it. That's going to be within that 3-month time frame. Usually within a month is usually how long it takes to get those set up.
Yeah. So that's kind of like an upper limit. Typically we get pretty fast value pretty quickly. You can, once you have you install PyAF, probably we've seen people get value out of this within the first week or so, within the first couple of weeks. We find what happens is we find you use your engineering intuition, prove something out, and then move forward with this thing. But it doesn't have to be a year-long data science marathon. Okay. The idea here is the end users here are typically process engineers, and we usually leverage your engineering intuition, and we should be able to hit the ground running pretty quickly. Okay. Do we have any other questions here? Can we do most of this without SEEQ Data Lab? Well, the idea here is that we need to bring in, we bring the Pi data in, we need to have that in. So how do we use the SEEQ workbench? I mean, I'm only familiar with using SEEQ Data Lab to bring data into the SEEQ workbench. Joe?
Yeah, so we have generic connectors to Pi that don't require SEEQ Data Lab at all. So you can just connect your Pi or Pi event frame data directly into SEEQ Workbench. So none of the workflow that you've seen here does require SEEQ Data Lab.
Oh, good to know. I also heard that you also have an event frame connector, right? And there was some talk about having it actually write data back into Pi to create event frames.
It doesn't write to event frames, but you can write back to Pi itself, which then you could create an event frame off of using the normal Pi tools. So you can create a new tag inside Pi.
And use Pi event frame generator to create the event frames. So correct. For those of you that are familiar with Pi, one of the big challenges is if you have a Pi FGen or using asset-based analytics, you have to do, unless you have a batch execution system, you have to do if this and this, you have to do a lot of if then statements. The nice thing about using that tool is you can use this as a way to do a visual representation to create these capsules. So I'll give a quick example. If you're doing a fermentation, right? I want to know when I'm in my, when I'm in my growth phase of my fermentation. Well, typically, from a control system perspective, when the valve opens up, okay, we are now in the growth phase. Well, in reality, it isn't until the temperature kicks off and the bugs start eating the broth. That's when you kick off. So you can use SEEQ to determine when is those profiles, when does that occur, look at it visually, and then use that to actually mark your event frames. So this can actually be used as a tool, as a more of a visual representation to create event frames back in Pi, rather than going through your traditional event frame generator. Okay. Okay, any other questions? I want to thank you, and I will ask you to please take the survey at the end of this webinar. And if you have any additional questions, or we can follow up with anything else, please reach out to me, jack@eisinc.com, or just shoot me an email, or just give me a call. All right. Thank you very much. And this concludes the webinar. I will send out a link to the recording. Thank you very much.